Hello everyone. So today I'm going to do a beginner session introduction to blueprints. So recently I got some suggestions to do something like this. So here I am doing a beginner series on blueprints. So today I'm going to introduce you the basics of blueprint programming that we can see, that we can use in Unreal Engine. Right, so first question is, what is blueprints? So actually blueprints is a node-based visual scripting language that we have within Unreal Engine to create gameplay systems. So that's the basic definition. So let's get into details a bit about that. So yeah, like this. Usually when we take Unreal Engine, we can either program our games in C++ or blueprints. So on the left side you can see an example C++ script, which is a normal programming language that you can write lines and lines of code to get this done. And here in the right side you can see some screenshot of blueprints. So here we have nodes and we can connect nodes to build logic. Let me show you an example C++ code. So this is our C++ hand-to-hand combat project character code we have developed in one of the other tutorials. So actually you don't have to understand this at all. I just wanted to show this as a reference. So this is how you write code in C++. You have functions, you have variables, you have interfaces, so like that, classes, usual stuff that you have in any programming language. So in blueprints, on the other hand, let me show you some of the blueprints. So this is our Unreal Engine open world project. So here we have this chest blueprint. If I open this blueprint, you can see, let me show you the code, the blueprint code, for example. So this is inherited from this VB resources. Let me open that as well. So here we have, see, when character overlap, when the player overlap with this, we get some pop-up to collect resource in this particular resource, or when character leaves this collider, that interaction goes away. So like that. So this is some blueprints. So actually we commonly call blueprints for this coding language, this node-based coding scripting language, and also we call this stuff we create, such as this chest and such as this explosive barrel. This is also a blueprint. And this dragon, this is a dragon character that the player can ride on. We call this the dragon blueprint. And here are some enemy characters, so we call them also like enemy blueprints. So we use blueprints like in two ways. First, to represent this node-based scripting language, and also to represent these entities that we have created using blueprints. Right, so now people, if you just check in the internet, you might see different opinions about coding and blueprints and C++. Like many people, people may suggest that it is not good enough, or it is, if you really need to do something, you might have to learn C++ or anything. But actually, despite of all those opinions, I can confidently say we can build any decent project, we can build any decent game in using only blueprints. It's completely possible. Let me show you some example in this game that we are working on, or everything we have created using blueprints. So this, all the gameplay logic, all the everything, all the gameplay logics is done with blueprints. We haven't used any C++ code here. And this game have all the elements that you can see in a usual third-person shooter game. We have stealth element, we have explore, we have shooting, we have grenades, we have searching, yeah, all the things that you can imagine in a usual third-person shooter game. So everything is done in blueprints. So I can say with confidence you can do almost anything with blueprints. Alright, so with that said, now let's get started and let's get our hands on blueprints and start learning. Because some stuff, rather than showing them in a presentation, it is easier and better to explain in the engine. Alright, so let's create a new game project, and I'm not going to select anything, so I'm going to select the blank template and to pp. No need to include starter content. Yeah, let's create the project. So while the project opens, just keep in mind the programming languages are for to build logics. So like we can create a sequence of instructions in a way the computers can understand, so computer will execute those instructions and do whatever we intend to do with the program. So whether it is node based or whether it is just like a typical programming language, writing code, so however we do it, the basic idea is building some logic, and blueprints is also just do that. So just like any other language, it is a programming language. So when you are creating with blueprints, it is same as coding, it is same as programming, like in any other language. What we are doing is building logics to get stuff done. Right, here I am not going to explain like this is viewport and these are the this is outliner, this is details panel, this is vertex. I'm not going to go through that because I assume that you are already familiar and you have some understanding in Unreal Engine. So I'll make this flow a little larger so we have some space to play around like this. Okay, now from this basic, let's drag and drop a cylinder like this. Place it like this, and if you go to this scaling icon, you can scale it up or down in any way you want, or you can just change the scale here. I'm gonna keep use 2 for the Z scale because I need it to look like sort of like a dummy character. And if you go to this move icon, select this move icon here, you have this move gizmo that you can use to move around this object. So here if you click on this in the world outliner, it will select the cylinder, which is the name of this object. So here I'll rename this character. You can just click on it and press F2, or you can right click, go to edit, rename. I'll call it dummy. Now when you play the game, you can look around and you have this cylinder. It doesn't do anything, but you have this default player controller class that you can just look around and move around. So that's all we have. Okay, so let's try to give some behavior to this cylinder. So for that purpose we can use blueprints. or we can use C++ as well, but let's see how to do with blueprints. So first, if you go to the blueprints, and there is an option to call open level blueprint. If I click on it, we get this blueprint window. So by default you have two events. These are called events with this red title bar. These things are called events. So, and this arrow, when you put mouse cursor over it, you can see exec. That stands for execution. So when I drag a line and put another node, for example, let's put print string. So this is a node that we can use to print some text into here or into the console. So this begin play, when you move your mouse over it, event when play begins for this actor. So this event will be called whenever you start playing the game, and this is for the, and as this is the level blueprint, this will be called when you start playing the game for the level. So just to show you that, I'll put text like game started and compile. So you have to compile in order to compile this code and do the necessary changes in order to reflect those changes in the gameplay. So now I go back to the game window and play. See, here we got game started, and it goes away automatically in a while. Here, game started. Right, that's the first event and first node you learned in Unreal Blueprint. And what is the second event? It's called event tick. This event is called every frame if ticking is enabled. So every frame of the game, this event will be called. To show you that, I'll drag, oh, I'm in the play mode, let me stop. Let me drag another line like this and start typing print. So you will get this print string as a suggestion. Click on it, so you get the print string node. Here I'll type tick and compile, and you see this tick is continuously being printed into the screen. So that means it is being called in every frame. Okay, now I'll delete this. Now I'm going to use these functions, events, to give some behavior to this cube. So this is the player start object. Since we have one of these here, when I start playing game, the player character will be spawned here. So I will put this, I will move this dummy over here, so when we start playing the game we can see it like that. Okay, right, now in order to make changes to this dummy, we need a reference inside this level blueprint. Let me save this level first. Let's create a new folder called maps, and I'll call it this level demo. Now it is here. So this blueprint is called demo level blueprint. Now in here, so when you select this object in the viewport, and when you go into the level blueprint editor, if you right click, you can see create a reference to dummy. Click on it. So here we have a reference to this dummy actor that we have placed in the level. Now let's say we want to move this character. When we play the game, we want to move this character to the right. Let me move this up a little bit so that we can clearly see when we start the game. Okay, so how do we do that? So in order to move, instead of teleporting this object to some place, some other place, we need to see this object actually moves. So, and this event tick is called once per each frame. So if I move this object little by little to the right using this event tick, we will see a continuous movement. So in order to move, what we have to do is we will have to set the location of this object a little to the right of its current location. So we can get the location using this node. So this returns the current location of this actor, and the return type is a vector. And also we can set actor location. Using the set actor location node, we can set the location of this actor to any location that we insert here. So now we have the actor location. Let's add another vector to this. So I'll say 1 in x direction, 0 in y direction, and 0 in z direction, and use it as the new location. Right. And nothing happens. Let's see why. Oh, mobility of this object, mobility of demorphosynchron level dummy static mesh component has to be movable if you'd like to move. Right, so if you want to move this, what you have to do is you have to set the mobility of this object to movable like this. Right, see, now it is moving, but right, so we set the x as you can see here, we added 1 to the x direction. So x direction means this red arrow's direction. So instead of that, let's add to y direction so we can clearly see the movement. See, now it is moving to the right. So that is your first logic implemented with blueprints. So right, now let's say we need another cube just like this in the level. So we can actually right click here, edit, duplicate. So we can duplicate this same object like this, or we can just like before drag and drop as well. So but if I play the game now, but only the first object is moving, that's because we have only changed in the location of this dummy object, and the other object name is automatically set to dummy 2. And if we want to move that also using the level blueprint, we have to do the same thing, get a reference to that object and create a reference here and set its location in the same way we did for the first dummy object. So this is not a very modular approach, and if you keep doing things like this, it will be very hard for you to create a complete game, as things is going to be very complicated if you are not using a modular approach. So using blueprints, we can, instead of setting the behavior of these objects one by one, we can convert this object that encapsulates that behavior to a reusable entity. So that means when we can create a blueprint, and we can reuse it in the levels, in multiple levels, and it will have the same behavior. So it will be clear when we do that. So for that, what we have to do is we can instead of just dragging and dropping here and setting the behavior here, we can create a blueprint. So first I'll create a new folder for blueprints. I'll call it BP. I'll save all the blueprints we create in this folder for this session. So there are multiple ways to create blueprints. First, of course, you can use this add button and use this blueprint class. Also in the create advanced asset, you have the blueprint option, and here also we have the same blueprint class option. Or you can right click in the content browser and create blueprint class, or you can select this object or even multiple objects in the viewport and click this blueprint icon, and here we have the option convert selection to blueprint class. So all of these ways are possible, but I'll use this way, blueprint class. So when you go there, we have we can select from many available blueprint classes. If you press on this arrow, you can see all the classes you need, and you can see the hierarchy here. All the objects are inherited from this base object class, and under that you can see we have actor, and we have various types of blueprints. So we don't need to go into detail on those things because we are just getting started. So here, which type of blueprint should I select? So the most basic type we have here is actor, and you can already see the description of that type. An actor is an object that can be placed or spawned in the world. So just something just like this cylinder. And also we have pawn. A pawn is an actor that can be possessed and receive inputs from a controller. So something that we can control as the player. And character. Character is a type of pawn that includes the ability to work around. Yeah, like a player character, a player human character, or maybe a player controlled animal character, something like that. So yeah, you can read these details, but for now let's focus on this actor blueprint. So I'm gonna select it. When you select it, we have a new blueprint created here. I'll call this VP dummy, and if I press enter, it will open this dummy blueprint. And when we create an empty actor blueprint, this is the default blueprint editor we get. We have the viewport. Here we can see all the components we have attached to this blueprint. At the moment we only have the default scene root, which is the 000 location of this blueprint. And we have construction script, and we have event graph. So construction script is something that we can use to initialize properties of this object when it is in the level. I will explain it more with an example. An event graph is here, just like in the level blueprint. We can see the begin play option, begin play event, and the tick event, and actor begin overlap event by default. So here also the begin play and tick do the same thing. This will be called in the beginning of the play, and this will be called in each frame if we have tick enabled here. Right, now first I'll go to the viewport. So here, just like for this cylinder, for this dummy object we have in the level, I need let's add some cylinder. You can do it like this: press on add components, and then if you go down you have the cylinder under basic shapes. Click on it, so it will add a cylinder as a child component of this default scene root. And I'll set the Z to 2 like this and save. And if you go to the map, now you can drag and drop this. Okay, you can drag and drop this dummy object. Now when you do that, you can see half of the cylinder is submerged on the ground. That's because the root of this object is here and cylinder is under there, and the cylinder is if I go here, cylinder's middle is overlapping with the default scene root. So if we want to cylinder to appear above the ground, well, of course we can move it up, but to make things easier, I'll give an offset here in the Z. If I go to the left perspective, we can see here is the default scene root. Let's move it like this. Now you can see for the object in the level as well, that change has been applied. Also, if you want, you can, let me add another cylinder object. Let's say for this object you want to have a different offset, so you can select this BP dummy 2, and then in the details panel you can select this cylinder, and here individually you can make changes. So the changes you do here will not be applied to other instances of this same blueprint or to this main blueprint itself. It will be applied only to this instance. But if you do some change here in the main blueprint editor, they will be applied to these instances unless we have overridden them in the level. So it is sort of a one-to-one relationship, or is it one-to-many? So anyway, from the connection, the changes will be applied from here to these instances, but not the other way around. Right, now let's replicate the same behavior we implemented in the level blueprint to move this object. Let's give the same behavior for these dummy objects as well. So for that, let me switch back to perspective mode here in the tick. So now since we are already inside this blueprint, we can use self to refer to this instance of the blueprint. So here we can set actor location like this, and I'll connect the execution pin to this node So this node will be executed in every tick. Now even if I didn't give a target to apply this node, it will by default consider we are using this node on this blueprint instance defined by self. So same way we can access the current location of the blueprint instance, this particular actor, using get actor location. And here also we don't explicitly have to give the self, because by default the system assumes we are trying to get the location of this actor itself. And let's add a vector like this and give it as the new location, and I'll add 1 in the y direction. Right, now if I play the game, you can see all that two instances of the blueprint BP dummy are also moving. So I'll remove these dummy and this cylinder from the level because I don't need them anymore, and I'll move these two into the middle like this, and I'll delete whatever this part I have written in the demo level blueprint, because I'm not going to use it anymore. And if I play the game, you can see these two objects are moving to the right. And to make things a little more interesting, let's see how to make these two blueprints move in different speeds. So for that we can use variables that you can see here in the variable section. Let's add a variable like this. So when we add a variable, it by default it will make a boolean variable. Boolean means true or false, but in order to define something like a speed, we will have to have a float type. So this float variable can hold a floating point number. So I'll rename this as speed, and I want to use this speed variable instead of this 1. So how can I do that? Right click on this small yellow pin and split struct pin. So we can convert this part into this structure. Now you can drag and drop this variable, and you can connect speed variable into any of these pins. So you can see this is green and this pin is also green, so it shows that we can connect these two because these are same variable types, so they are compatible. So I'm going to use it for y. And if you select speed, here you can see the default value is 0. So if the value is 0, this will not move at all, as you can see here. So I'll make it 3 and compile. See, now it is moving faster. But both dummy objects are moving in the same speed. So how do we make these objects to move in different speeds? For that, we should be able to edit that speed variable for each instance. So if I go to the blueprint again and click on this I like icon, it will open. So what it does is it makes this variable public and editable on each instance of this blueprint. Now if I compile and select this dummy object, you can see here under the default section speed, so we can edit this. So for the first dummy, I'll set the speed to 1 and play. Now see, the first dummy is moving slower compared to the second dummy. Great. Okay, so now you know how to create a blueprint, and now you know how to use the tick to implement a simple behavior, and now you know also how to use variables. And we didn't talk about this construction script yet. So as I said before, we can use this construction script to initialize this object. For example, let's set up a simple way to change the color of this cylinder, and this cylinder is using the basic shape material. So let's go to the content browser and let's create a simple custom material that we can control, that we can change the color through the code, through the blueprint. So I'll name, you can create a material like this. Right click and you have under blueprint level material. I'll name it as color, and when you open it, you have this material node, the main material node. Drag a line from base color and type vector parameter and enter and call this color. Right, now double click on it and you will get the color selection panel. So I'll use this color as the default color. Oh, it's pink. I like this color better, and apply. So yeah, that's all we need for the material, and I don't really need to focus on materials in this tutorial, only on the blueprints. So now how do we assign that material? Well, there are a couple of ways. First, you can use this one, and since we don't have any other materials, we can see it clearly here, and we can select it. Or you can go here, drag and drop in here, or you can select the same color and use selected asset from content browser icon, this arrow. So if you press it, it will be assigned. Right, now when I change the color here using the material, you can see that change has been applied to all the instances in the level. Right, now how do we change the color? So for that, in the construction script itself, I'll drag and drop this cylinder into the construction script. It will create a reference to this cylinder component, and drag a line from this from the cylinder reference and type set vector parameter value on materials, and the parameter name we used was color. Let me copy that and connect. Now here we need a way to define a color. So press on variables, and here let's say, do we have color? Let's call this dummy color. and I'll make this one also public. So how can we set this color as a parameter, because this is a color variable and this is a vector variable. If I split this, we can access R, G, B and alpha values, and I can also split this vector here as well. Oh wait, I think instead of color there is another variable type called linear color. Yeah, so this represents color in a 32-bit floating point numbers. So let's change it. See, now we can see colors as RGBA values, and these are in float values. So I'll connect R to X, G to Y and B to Z. So we can't connect alpha value here, but that's okay. And as the default color, I'll use red and compile. Now you can see this has been changed to red. So if I change the color to blue, you can see that change is directly applied to this object, because this construction script executes in here in the blueprint editor as we do changes to any of these variables, and also it executes in the editor as well. So here now if I change, now I'll select the dummy one and change the color to any other color other than this light blue. So you can see that change is directly being applied to the object but not the other object, as I explained before, because this change is only specific to this particular instance. And this is very important, like when you setting up tools for designers who don't understand blueprints, we can create simple functions like this to facilitate the designers so that they can easily change the colors and they can easily change other properties in order to make the level. Let's make this another color, blue. Right, now we can see we have two dummy objects with different colors. One is pink, one is blue. Okay, and now you know basically how to use the tick and how to use the construction script, and also you know what is begin play. So, and you have basic understanding of the viewport of the blueprint editor. So yeah, before wrapping up the session, so let's say now we have two blueprints that has different speeds. Now let's say we need another blueprint that it should have it should have a different movement behavior. So instead of just constantly moving to the right, it should move to right and then move back to the left and then move back to right, so kind of a oscillation. So how can we give such a behavior? Well, obviously we can modify the code here, but then it will be applied, that behavior will be applied to all of these instances. So now let's use one of the OOP principles, object oriented programming principles, inheritance. So we can create a child blueprint class using this BP dummy. So yeah, I'll just call it BP dummy child and open it. So since this, let me first create an instance of the child here. I'll make it yellow, sorry, green, and as I haven't done any change, it behaves in the same way, just like its parent blueprint. So yeah, if I open that blueprint, and same as the parent blueprint, it has the speed variable and the dummy color variable. And you can see begin play calls the parent begin play function, and this actor begin overlap, which we are not actually using, also calls the parent function, and event tick is also calling the parent tick. So if I disconnect this execution pin line and play the game, you can see, oh, it is still moving. Wait, why? Alright, actually this is disabled because this is grayed out. So let me add something like another print. Oh, now it is colored up, so it is enabled. And yeah, now it stays in the same place and it keeps printing hello. Now let me delete this. Now it should stay in the same place without saying hello. Okay. So now, yeah, now since I have disconnected the parent tick function, it is not moving at all. So yeah, let me completely delete this. So how do we make it have an oscillation variable, oscillating behavior? Same as before. Let me copy this part. Wait, no. Actually, we can use the same part. Parent. Okay, how can I get back the parent? Yeah. Actually, we can use the same function, and all we have to do is time to time changing this speed variable. So instead of 3, if I set it to -3, it will start moving back. So now it is again moving. Okay, so call the parent tick function and also get the speed variable, sorry, not the speed variable, get actor location, and it gives us the location of the actor and split this. So if this y value, so what's the current y value? It's -30. Okay, so if this value is either larger than +100 or less than -100, so in any case, if that happens, we need to revert the speed direction. So how can we identify that condition? Yeah, we can get the absolute value of this y, and if this value is higher than 100, branch. So this is like a if condition in usual programming languages. So if this condition is true, it will execute this part. Otherwise, if it is false, it will execute this pin. So if this becomes true, what I am going to do is I'm going to set speed value with the negative of the same value. So get speed, multiply this. You can multiply with if you press star, it will get the multiply, and use float with float. Here use -1 and connect. So what this part does is, if the absolute value of y is larger than 100, it is going to set the speed. Basically it is going to revert the speed's direction. If it is 5, it will become -5. If it is -5, it will become +5. Right, now let's see. Now it is oscillating, and obviously I think we can increase the range a little bit. Instead of 100, if I use 1000, you can also convert this to a parameter as well, but no need to do that. Okay, so see, now it is oscillating. So that's how you use inheritance and how to override parents functions, parents behavior to create new behaviors while using the same properties and same things that you can use that inherited from the parent. Okay, so I think that would be enough for a blueprint introduction, and thanks for watching. So let me know in the comments if you would like me to cover more of this beginner stuff in future, and also if you have suggestions like things that you would like me to cover in more beginner friendly way, just comment them also. And thanks for watching. If you would like to support my work, you can get the membership of the Patreon club. Link would be in the description below. And if you are a member of Patreon, you will have free access to all of these project files that I have done in my channel. So see you in another episode. Goodbye.